Good morning, everybody. Welcome to another edition of the Lab 207 webcast. My name is Mr. Kite, and I'll be hanging out with you today as we continue on in our series about energy resources. Topic for the day is going to be hydroelectric and geothermal energy. So as always, let me get you some objectives. I won't get going. By the end of this video, you should be able to describe the processes of generating electricity and geothermal energy, and then explain the benefits and drawbacks of each type of energy. So that's what we got for the day. Adding on to our list of renewable energy, starting with hydroelectric energy. So at its base level, hydroelectric energy is electricity generated by the kinetic energy of moving water. And we've talked many times about generating electricity by turning a turbine, which turns a generator, which creates electricity. In this case, you have got water turning the turbine to generate the electricity. So that would be hydroelectric energy at its most basic level. If we talk about around the world, who does it, who does the most of it, etc., on the whole, it's about 20% of global energy generation. So by and large, hydroelectric energy is the most common form of renewable energy generation around the world. The leaders in the production of hydroelectric energy are China is the world leader, followed by Brazil, followed by the US. So those are the places that are doing it presently. In America, we really are kind of at our maximum capacity. Most of the rivers that could be dammed up for hydroelectric power have been. So as far as hydroelectric energy goes, the USA has pretty much tapped out, but there are a lot of other places in the world that could be set up to run on hydroelectric power. So as I mentioned just a second ago, the way that we create electricity using hydroelectric power is by storing water, which runs a turbine, which creates electricity. Here's just a general water impoundment system. So you've got your dam. Dam blocks the river, which creates a reservoir. This is your water storage. Within the dam, there is a water intake. The water goes in, it flows through the turbine, which is right here, which turns the generator and gives us the power and the electricity that goes out to our power lines, and then the water just flows onto the dam. So it's a really simple system. There are three forms of hydroelectric power generation. I'll talk about each one, but know that they all use this basic principle of water turning the turbine, which turns the generator, which creates electricity. The first type of hydroelectric system I want to talk about is called a run-of-the-river system. A run-of-the-river system does not use a dam. It does not use any sort of water impoundment. Rather, it's just got short little tiny dams that slow the river down a little bit and then channel the water through a cement channel, and then it uses small turbines in order to create the electricity. Some of the benefits of a run-of-the-river system is that there's no flooding involved, and that's a big deal with other projects. We'll talk about that in a second. Seasonal variation in the river is maintained, so the river is able to rise and fall as it would naturally, so the ecosystems aren't as disrupted. This is probably the most environmentally friendly form of hydroelectric energy generation. It does have some problems, though. The power generation is usually pretty small because you're not storing water, so you are kind of bound by the flow of whatever river you are using. Also, because you're not storing that water, if the river goes down, you're not generating electricity. So those are some of the problems of a run-of-the-river system. So the next type of hydroelectric energy generation I'm going to talk about is an impoundment system. Now, when you think of hydroelectric energy generation, you are usually going to think of impoundment. You kind of envision a dam. Behind that dam is a big old reservoir of water, and then the water flows to the turbines to make electricity. So one of the major benefits of a water impoundment system is that you get energy on demand. You are not bound to seasonal rises and falls in the river or anything like that. You store your water when you need water. When you need more electricity, you open the flow gates more. When you need less electricity, you close the flow gates down. So you got a lot of regulation on it. The biggest and best known hydroelectric project in the world is the Three Gorges Dam in China. And over on the next slide, we're going to talk about some of the benefits and the drawbacks of hydroelectric in general, as well as the Three Gorges Dam. So looking at the benefits and drawbacks, here are the major things that you need to know. It is a clean form of energy. So once that dam is built, obviously the building of the dam uses energy. It produces greenhouse gases. it's severely disruptive to the environment where the dam is being built. But once that dam is in place, it produces absolutely clean energy with no greenhouse gas emissions or anything like that. As far as cost goes, it's actually less expensive than nuclear energy, and it's less expensive than natural gas. So it's a fairly cost-effective way of producing electricity. Also, other benefits you get away from the electricity generation, you get flood control. So if a river was prone to flooding beforehand, you stop that river with a dam, you can control the flow of the river beyond the dam. You got a recreation area in the form of a reservoir that people can swim on, boat on, fish, whatever. You also have water storage for drinking water later on, or irrigation for farmers. Also, it's high capacity. A hydroelectric power plant can turn out gigawatts and gigawatts and megawatts of power. So you can get a ton of power out of these things. Now, the drawbacks that people point to when it comes to water impoundment systems is first, upstream flooding. This was the big problem and the big controversy with the Three Gorges Dam. When they built that dam, the river that it stopped flooded, obviously, to create the reservoir, but over 1 million people were displaced from their homes. Farmland was destroyed. You had really significant archaeological and historic sites that got flooded out. So anything that is behind the dam gets covered over in water, which obviously is a problem. You also get changes in species composition because rivers that are flowing are usually fairly cool and oxygen rich, but water that's sitting behind a reservoir is stagnant and it's usually warmer, so the oxygen content is lower, so different species are going to start living in that area as opposed to the flowing stream. Also, the downstream ecosystem is significantly changed because you don't have water flowing freely, you don't have seasonal variation. The river does still run, but it's in a much more controlled way, so you don't get the buildup of sandbars or things like that that you would normally get with a naturally flowing river. Fish migration routes are a problem because if you put a dam in the way, fish are going to have a hard time migrating through there. And then there's siltation and greenhouse gases. Siltation. As rivers flow downstream, they carry sediment with them. When the water hits that dam, the sediment gets deposited behind the dam. Now there's a twofold problem here. That sediment would have normally gone downstream and enriched farmland during natural flood cycles, so that doesn't happen. Second thing is that silt builds up behind the dam, reducing the amount of water that can be stored behind the dam, and also as that silt decomposes and as any farmland that was covered over by the farmland, trees, forests, whatever, that was covered over by the water breaks down under anaerobic conditions, they release tons of methane, and we've talked about methane being a highly potent greenhouse gas. So you need to know the benefits and the drawbacks of hydroelectric energy generation. Let's talk about tidal for 1 second. And tidal energy just depends on the movement of the tide. So it's not like a flowing river or falling water, it's just the tide coming in and going out. Obviously, this is going to be location specific because you have to do it in an area where the tide moves in and out enough to actually get sufficient flow to create electricity. Unfortunately, tidal power plants would be built in systems or ecosystems that are pretty sensitive. So it's going to be like aquatic habitats by saltwater marshes or freshwater marshes. So building these sorts of power generation plants could be hard on the environment. And let's go ahead and switch over to geothermal energy real quick. This is the only renewable energy source that is not derived from the sun. It harnesses the radioactive decay in the center of the earth that produces heat. It takes that heat and then uses that heat in order to generate electricity and do some other things. So first, recognize that geothermal heat is not derived from the sun. As far as people, places, countries that are able to do it, the major geothermal reserves in the world are in USA, China, and Iceland. All three of those countries are presently producing electricity using geothermal heat. Iceland does a tremendous amount of geothermal heat and electricity generation. The USA, we've got some. Each one of those dots represents some sort of geothermal plant, and then China is able to work on it as well. Now, the interesting thing about geothermal heat, and one of the problems, is that it's location specific. You can only do this in areas that have geothermal reservoirs. So a couple ways that you can use geothermal heat. One of them is for heating the home. Iceland heats 87% of its home this way, and basically what it does is you take the hot water from the ground. So you got radioactive decay, it heats up the earth. When water deposits underground, so groundwater gets near that warm earth or the warm mantle, it heats up that underground water deposit. You can take that water, run it through pipes in the house, and then it just radiates heat out to the rest of the house. So This is a good, cheap, easy way to heat the house because you don't really need a furnace. You just need a pump to pull that hot water out of the ground and then circulate it through the pipes in your house to warm up your house. You can also use it to generate electricity, and the way that this basically works is not a hydroelectric, a geothermal power plant kind of works like this. You've got your mantle down here and your groundwater deposit that is being heated up. You pump that hot water and the steam up and into your power plant. At that point, the steam that is generated from this water turns your turbine, which makes electricity. You then recapture that steam, condense it into water, and you pump it back down into your deposit to be heated up again and run the cycle all over. So rather than burning coal or nuclear fuel or whatever to heat up your water, you are using the natural heat of the earth in order to heat this water to make the steam you need to turn your turbine. Two problems with geothermal electricity is water depletion, so you are using groundwater. So there's the possibility that if you use too much of that groundwater, those groundwater resources will go away. There are also some toxic gases and steams that can be released from geothermal deposits when they are opened up and the energy is extracted from the earth. And finishing up with this, you need to understand a ground source heat pump. Now, first thing that you need to know, ground source heat pump technically is not a form of geothermal energy because you're not using the heat that is generated from the inside of the earth. You are using the fact that earth, like the soil and the crust of the earth, has high thermal inertia, which means that it heats and slows very slowly. So once you get down about 10 feet underground in most parts of the world, there's a pretty stable underground temperature between 50 and 60 degrees. And what a ground source heat pump does is capitalize on that energy to either heat or cool the home. And here's basically how it works. Just going to give you a little walkthrough here. You have got a fluid-filled pipe that is drilled down into the earth. And so let's say it's wintertime and you need to heat up your house. The way this works is you take and you pump like an antifreeze fluid down. It goes through the earth. As it goes down there, it pulls in some of that heat from the earth. So let's say it's 30 degrees outside. The underground is 60. This fluid would get heated up to about 60 degrees, and then it comes into a compressor. When you compress a fluid, it heats up, so your compressor compresses that fluid, it heats up and goes into the heat exchanger, which would heat air that would then be circulated through your house in order to warm the house up. If it is wintertime and you need to, or not winter, if it's summertime and you need to cool your house down, this heat exchanger, all of the warm air in the house would run through this exchanger. It would heat up the fluid in the exchanger. That fluid would be run down into the ground. Once it was into the ground, it would take the heat it had picked up from the house, transfer that heat to the ground and cool off, and then the cooled liquid would be run back up into the house to cool the house, and so on and so on. Now, a ground source heat system is really cool because they're 30 to 70% more efficient than a traditional furnace or heating unit. So know that, be aware of how it works. Also be aware that this technically is not geothermal energy because you are not using the heat generated from the mantle of the earth. You are using the fact that soil and ground in the crust of the earth heats and cools very slowly. And that's it. I feel like I've rambled a bit. My apologies. Hopefully you got a little better understanding of hydroelectricity and geothermal heat. Thanks for joining us on the Lab 207 webcast. My name is Mr. Kite. We'll see you again.